Greetings everyone, myself Pranil and the topic for the image processing and computer vision mini project is cartoonify an image using OpenCV. So my department is Electronics and Communication Engineering, and so uh, and exact this topic, the cartoonify an image using OpenCV, is an exciting example of how a computer vision can turn an ordinary photograph into artistic cartoon-style image in real time. This project combines classical image processing technique, no deep learning, just clever math and filters to create something visually appealing. So, cartoonify is basically a process of giving a photo a drawn or animated look. It merges three main operations. First is edge detection, which finds the outlines just like an artist pen sketch. Second one is the color quantization, where we reduce color variety so that the image looks flat and less photorealistic. And last one is the smoothing, which removes the texture but keep the edges crisp. Applications, we can see them daily in the Snapchat or Instagram filters, digital art, and even in the animation pipelines for visualization. So, okay, the one more application could be like right now when I'm talking with all of us. Then if I want to change my background, then what can I do is just simply I will mark the edges of my face, and apart from that, rest all can be blurred or either I could be synced back to space and all. And these are some of the applications. So let's begin with our workflow. So here's the workflow. Uh, we will be starting with a real image, then convert it to grayscale, detect its edges, smooth the colors using filters, and finally combine both results to produce the cartoon effect. Each step builds logically on the previous one. We just simplify the image, then style it. So, next, moving on with the image preprocessing. First, we load and resize the image for faster computation. OpenCV reads image in BGR format and we convert them to RGB for proper display in Matplotlib. Then we convert the grayscale because edge detection doesn't need any color. Mathematically, the grayscale intensity is the weighted sum of red, green, and blue channels given by the formula I gray is equal to 0.299R plus 0.587G plus 0.114B. This gives the brightness consistence with human perception. Then, moving on to next slide, which is noise reduction will reduce the small unwanted variations using a median blur filter. Unlike averaging, median blur replaces each pixel by the median of its neighbors, which smooths region but keeps the edges sharp. It is defined by the formula is I blur is equal to median of I gray of ij and belonging to ij for ij belongs to n of x comma y. So here is a sample image of how it will reduce the noise and make it average. So what we'll do is basically a matrix of 1 by 9 in bracket of 1 1 1 1 1 1 1 1 1. For example, we can consider this kind of matrix which can be used for the noise reduction, that is median blur, that is taking median of all other components in that region. Then the next step would be edge detection. Edges form the backbone of a cartoon look. We can use adaptive threshold or canny edge detection. Adaptive threshold calculates the local threshold T local for every small region, producing cleaner outlines even when under uneven lighting. So E of x comma y will either be 255, that is white, if I of x comma y is greater than T local, or 0, which is equals black if otherwise. These outlines are what will later will appear as a cartoon's bold strokes. Then the color smoothing. Color smoothing. Now we will make the colors look like flat and painted. A simple blur would destroy edges, so we will use the bilateral filter. It smoothens the similar colors within the range while preserves the boundaries. Its formula is given by this. Here we can observe that the image is not getting completely blurred, where the similar colors within the region will look like it will get smooth over the region considering its boundaries. Its boundaries are unharmed. If we observe over here, the boundaries are unharmed, but on other hand, there is a clear visual where the color has been changed. So, moving on to next step, which would be combining edges and smooth effect. Finally, we overlay the detected edges on top of the smooth color image using bitwise AND operator. So, I of cartoon is equal to I smooth bitwise AND with the E. This step further structure from edge map with the vibrant simplified colors, and voila, the image looks hand-drawn. So, this is our image before, and this would be our cartoonization. So let's recall it back again. What all steps we did? First step was image preprocessing. Next step was noise reduction using median blur filter. Third step was edge detection using canny edge detection or adaptive thresholding. And last step was color smoothing by using bilateral filter. And all of this combining will get a to combine edges and get a smooth image. We get iCartoon is equal to iSmooth bitwise AND with E, and this will give our image. Now, implementation in OpenCV. This is a Google Python code implemented in Google Colab. We'll look at the code later in this part of the video. We import OpenCV, NumPy, and Matplotlib. After uploading an image, we convert the RGB and resize, convert the grayscale and blur it, apply adaptive thresholding to get the edges, run bilateral filtering on color images, and combine both results. The output shows three windows: the original, the mask edge, and the cartoonified image. The whole process just takes a few seconds on Google Colab's free GPU or CPU. We'll run the code right now. So this is our code. Here we install the necessary requirements and we import the necessary libraries. Then later in the part of the code, we can see that conversion of RGB to resize, then conversion to grayscale, then later median blur to reduce noise, then detect edges and adapt to thresholding, then applying bilateral filter to smooth colors but preserve edges, and then combining everything to get our final product. So we'll run it in the loop and we'll get our access this, and we'll mark our image very cleanly to get our output. So we'll run this code right now. This was already done by me before, but yeah, we can use for any other images. A bit of a delay here, but yeah. So we can choose the image which we want to cartoonify. Here we have SpongeBob. We have so we'll go with our Messi photo, and yeah. So this would be the three parts which we had to show: the original, the edge mask, and the final cartoonized image. So yeah, so the here are the sample results. The difference is clear. We can see the edges are bold, the textures are gone, and the colors are smooth and blocky. The mimics the style of the hand painted or the shell shaded animation. You can experiment by changing the parameters. More blurring gives more soft watercolor look. Sharp edges give an anime style result. So discussions. This is our result, which we copy pasted from there. And yeah, parameters. Parameter tuning is what defines the cartoon smooth. The the text block size controls the edge density. Larger values create thicker outlines. The sigma color and sigma column define how strong the smoothing is. Real-time applications include webcam filters, artistic renderers, or pre-processing for style transfer neutral networks. This technically is lightweight, so even can run on mobile devices. So we have its real-time applications. So, conclusion. To summarize, cartoonification is a great demonstration of classical image processing power. It merges edge detection for outlines, bilateral filtering for artistic smoothing, and bitwise masking to combine results. The beauty is that it's real time, easy to implement, and produces results that look like a digital art without heavy AI models. So, in short, by understanding how edges and filter work, we can make machine draw like humans. These are the references which are used. The technique we used in detail we used are detailed in the OpenCV official document, the Gonzalez and Woods classic text digital image processing, image search tutorials on Cartoonify using OpenCV. These are great resources if you want to dive deeper into image filtering and computer vision fundamentals. So this was all about our topic, cartoonification of an image using OpenCV. Apart from that, it was just an excitement for me to understand how the trend, which was going on before 5 or 6 months, which was Ghibli trend. So we know that the OpenAI CEO came forward and said that their GPUs are burning, and please stop making those images. So I wondered that how those things work. So basically, the thing will work as there will be your image and there will be the Ghibli art, a reference image. Both of the image will have the respective histograms, and then when we see their histograms, we can balance their histograms to get a good effect of one on each other. But this process is highly slow and takes multiple iterations to override things and give your image that art. So here I have tried a small code upon how to create how to convert your image into any style which you like. Ghibli is a recent trend. Apart from that, there are many trends that show the prompt and all. Even I have tried here the Vincent Van Gogh's famous Starry Nights as an example of styling. So here is the code. So here is the content image taking and style image. Then later loading of the images can be done here. And so this is pre-trained values. We can check out the code later and getting the features, getting the gram matrix, and the after the number of steps equals to 100, then we can say that it is somewhat converted to the style which we desire to have. So saving our time, I had already run the code. It takes a lot of time, so that's why I have already done it. So here's a simple image of a bird. It was a pixel size of 512 x 512, yet good bytes. And the next style image will be of Vincent Van Gogh's Starry Nights. So it is of bit size of 248037. So after that, if we see, then it will start its work, the torch and epoch. And step one, there will be a lot of loss. Later, which it goes on reducing over the steps of 25. We have taken step size of 25, 25, 50, 100 will be the outputs that will be shown. 50 and 75 and finally the 100th one. So, as we can see that for a normal vision, it makes no difference. But if we observe the edges over here and in this one and in this one, eventually it has tried to make the effect of this over there by matching the histograms or in a other way in a deep learning CNN method. So this were some of the interesting topics which I felt, and I I love to discuss with all of us, and I hope this video was interesting. Thanks a lot.